Good afternoon.
Good afternoon.
Hi.
All right. Thank you. Let's see. St. John's, could you guys lower your camera just a little bit? Oh, perfect. Thank you. All right. So looks like we have anybody missing in Mogyan?
Yeah, everyone's here.
Everyone's there? Okay. I wasn't sure if Denon was there or not.
Yeah, he's just outside.
He just stepped out for a sec.
Yeah.
Okay. All right. Thank you. All right. So, any questions, concerns about the quizzes today? Let's see. I think everybody's taking them, right? Okay. All right. Well, okay. So today we are hopefully going to finish up 2.6 and maybe get into 3.1. I don't know. Just depends on what our time is like. But we should finish 2.6 here today. All right, let's go ahead. So any other comments or questions before we get started?
When will the chapter 2 test be?
Okay, so probably 2 weeks from today.
Okay.
So because next week we still have to do the 2.6 quiz before, and I said that I wouldn't give you a quiz and a test the same day, right?
Yeah.
So that means we'll do 2.6 and then maybe 3.1 or something like that, and then we'll do the chapter 2 test the following week. So 2 weeks from today. Okay. Let's see what else. Oh, and I hope you don't mind me talking about this publicly, Joey, but you had a question about the 4-H thing, right?
Yeah.
Yeah. So here's my deal: is that typically, and this is just for everybody, that when you miss class, if it's a school absence, then you watch the video, you let me know, and then you get the points for the attendance points for that day. Now, couple of things. The videos, there was an entire week when nothing taped. Okay? I think it was last week or something. I think we actually canceled class one of those days, but so that maybe is good. The second thing is that this week the videos are late getting up, but the guy that does that, he does a great job. And so I know that the videos from this week, for example, will be coming. But going back to your particular thing, and I do appreciate the question. And in my opinion, see, there's a lot of schools that have 4-H clubs. And so while that's technically not for your school, a school absence, I'm going to count it as an educational thing. And so I will let you make up those attendance points for that day if you just watch the video and then just shoot me an email saying the date. Like I was absent on this date, I watched the video, and then I'll update your attendance. Okay, so I've got to get that going. So anyway, so it doesn't hurt to ask. Okay, and if it is like an educational thing, and Joran going on a cruise to the Bahamas, that's not going to count. So sorry, you don't get to count those as an educational experience. Sorry.
If the videos from last week aren't up, I had a soccer game last week.
Yeah, that's what I'm saying. I'll double check and I'll let you know. But I think the videos from last week didn't get taped at all. There was something messing up with the actual recording function. And so if you want to, if you were out with a soccer match, let me know the specific date And probably what I'll do in that case is just if there is no video for that day, then I'll just say get the notes from somebody and we'll call it good, and I'll give you the points if there's no video available.
Okay, thanks.
Okay, and I'll try to let you know tomorrow. I'll try to get everything up to date as far as I can, like maybe through today or something like that. And so then you'll know for sure if the date you were gone. If the video isn't up there, then let me know. Okay? That's the only way I know how to do it. If you have another alternative plan, I'd love to hear it. So, okay? Anything else? I appreciate those comments. I think that helps everybody. All right, well, let's get started. We're on part 12 on the back side of the 2.6 Student Success Organizer, and ready to go. All right, here we go. Okay. Okay, so we talked about rational functions can behave in various ways near the vertical asymptote. And so that's kind of what we're looking at next. So when we have, like, say, the limit like this, as x approaches 2, okay, this is a situation where when you plug in the number, you're going to get 0 over 0, okay? So that means you got to do something else. And so typically the first thing you try to do is factor and cancel. And so here, when you cancel that factor, x minus 2, at x equals 2, what makes that go to 0, that causes a hole, okay? So we've talked about that and how to plug in the hole and so on. Okay, but now we want to focus on this other factor that doesn't cancel. So the x plus 2 here, that's going to cause a vertical asymptote at the value of the function that would make that go to 0. So that would be at x equals negative 2. So at x equals negative 2, you're going to have a vertical asymptote. And so what we're interested in is what would happen on each side of that. Now, on this one, if it's just x equals 2, once you factor and cancel, now if you plug in again, you'll get 0 over 4. So 0 over 4, that limit is just 0. So if you factor and cancel and then plug in again and you get a number, then that's your number. Okay, that's your answer. Okay, but now this one, let's see, as x approaches 2, we get 0 over 0. Okay, now this one, if everything cancels in the numerator, then you think of it as a 1. Okay, here we'll put a little 1 up there in red. And so now when you plug in 2, you get 1/4. Okay, so we've done those type before. Okay, but this one here is x approaches 2 from the right. Again, you try plugging in 2, you'll get a 0. You'll get a constant over 0. So it's not 0 over 0 this time. 2 minus 3 would be negative 1 over 0. And so when you have a constant over 0, then you know the answer is either infinity or negative infinity. Okay? So then you think, all right, if you plug in values slightly bigger than 2, like say 2.1, minus 3, that's going to be negative. Okay, anything, 2.1 squared minus 4, that's positive. Negative over a positive is negative, so you know the answer is negative infinity. Okay, so anytime you have a constant over 0, then that's going to be either infinity or negative infinity, and you need to watch the signs and figure it out from there. Okay, so looking at the graph, see again, if you get stuck, put it in your calculator, and you can say, well, as x approaches 2 from the right, the function goes to negative infinity. So you can kind of see that from the graph. All right, any questions so far? Let's see. Okay, then the limit as x approaches 2 from the left, you can see would be positive infinity. Okay, so then since the left and the right don't match up, then the limit in general as x approaches 2 does not exist. Okay, so since they don't match up. Okay, so then now this one, okay, you remember the trick when we did the factoring and canceling, that 2 minus x and x minus 2, you can actually cancel one of those, but you're left with a negative 1. So it's like factoring out a negative 1, then you can cancel one of those factors. And so now, as you look for what happens when x approaches 2, you're not going to get 0 over 0. You're going to get a constant over 0. So that means your answer is infinity or negative infinity. Since the denominator is squared, it's always positive. So a negative over a positive, so your answer here would be negative infinity. All right, so let's have you do practice 12. So I'll do all 6 of those problems, please. All right, so Joey, when you got the first one?
0.
0 is correct. Good job. Any questions? So if any of these you get wrong and you want me to work through it, just please holler, let me know. All right, Nathan, the second one, please.
Positive infinity.
Okay.
Positive infinity. Nope. Okay, so let's go through this one. So when you plug in 3, you get 0 over 0. So that's not good. Okay, so that means you see if you can factor and cancel. So you factor the denominator, and the x minus 3's will cancel. So then you plug in 3 again, and you get 1/6. All right. You see where what you did wrong on that one, Nathan?
Well, yeah.
Okay. All right, good deal. Go to the next one. All right, David, what did you get for C?
I think we will find out in just a minute.
David. C.
Oh.
I got negative infinity.
Negative infinity is correct. Good job. All right, D. Nathan.
Positive infinity.
Positive infinity is correct. Now we're picking on the St. John's guys today.
Can you go
Let's see if-
over that one, please?
You bet. You bet. Okay. So first, if you try plugging in 3, then you're going to get -1 over 0. So anytime you have a constant over 0, then you know that you're going to get either infinity or negative infinity as your answer. So what you have to figure out now is the sign. So here, if you plug in a value slightly to the left of 3, so to the, like say 2.9. 2.9 minus 4 is negative. 2.9 squared minus 9 would also be negative. So you get negative divided by negative, so it's going to be positive infinity. So is that okay, Chloe?
Yes, thank you.
Okay. Any other questions on either of those? All right, let's go to the next one. We're still on wheel 1. So Rachel, E.
The limit doesn't exist.
Does not exist. That is correct because the left and the right hand limits weren't equal. Great job. And F. David again.
Would it be 0?
Would it be 0? No. So again, this one is just a general limit. So as x approaches 3, so you plug in 3 and you get 0 over 0. So you try to see if you can factor and cancel. So the x minus 3, and you can factor out a -1 and write the 3 minus x is x minus 3. So the x minus 3's will cancel. So you have -1 over x minus 3. So then you plug in 3 again and you get 0, but not 0 over 0. You have a negative over 0. And so then that means your answer is anytime you have a constant over 0, you're going to get infinity or negative infinity. Okay, so now it's a little tricky here because as x approaches 3, see if you approach 3 from the left, you get negative over a negative, so you'll get positive infinity. As you approach 3 from the right, you'll get negative over a positive, so you'll get positive infinity. Or excuse me, negative over a positive would give you negative infinity. So the answer is it does not exist. The limit does not exist. Okay, so that one's a little tricky because you think that you just plugging in the number is going to work. But whenever you have a constant over 0 and the answer is going to be infinity or negative infinity, you actually have to look at it from either side of the vertical asymptote. So you have to approach it from the left and from the right and do both of those limits. Okay? All right. Any questions on that? Whoops. Okay, now let me just say that, okay, so when I'm taking a quiz or a test on this, I would definitely have like the guided notes, this stuff in front of me to remind me to check that. And paying attention in class and going through this, you guys, you do a great job, but it's not enough. You do need to practice. And I had one of my trig students today that was really frustrated that, he's used to being an A student. And he's like, I pay attention in class. I understand what's going on. I've got my notes in front of me. And I'm like, well, are you practicing? Are you doing some of the practice problems? And he's like, no, he's just trying to take the quiz based on what we do in class. And unfortunately, math doesn't work that way. You learn a lot of subtle lessons by doing the practice problems. So let me just put in a word for that. It'll help you when you're doing quizzes and stuff if you've practiced. Okay? All right. Well, enough of that. Let's go on part 13, rational functions at infinity. All right, so that's where, when we talk about the functions as they go to infinity, then that, or negative infinity, that's where you compare the powers of x, okay? And so now we're focusing on specifically when you have an oblique asymptote. Whenever the power is greater in the numerator, then you'll have an oblique or a slant asymptote, and the answer to the limit is going to be either infinity or negative infinity also. So if the power is bigger in the numerator, the answer is going to be infinity or negative infinity. Because, see, like here you have a slanted asymptote. If the graph is going this way, it's going up to infinity. If it's hugging the asymptote down here and it's going down, well, then it's going to go to negative infinity. So you just kind of have to either logic it out or look at the graph. So that's kind of what we're going to do here. All right, so here is the limit. So when the limit is approaching infinity or negative infinity, that's when you compare the powers. Okay? That's when you compare the powers. So here, the power is bigger in the numerator, so your answer is either infinity or negative infinity. Okay? So you've already got it down to a 50-50. So now, if you imagine like what we did before, you can see that where we divided by the highest power of x in the denominator, then see what you end up with is, see, x to the 5th over x squared simplifies to x to the 3rd, minus 6x squared plus 1 over x squared. And then the denominator, this will simplify to just 3, 1 over x minus 7 over x squared. Okay, now remember, the answer is going to be infinity or negative infinity. Okay? So, if you think about plugging in infinity, then you end up with negative infinity cubed times 2 is negative infinity. Negative 6 times infinity squared is negative infinity. A constant over infinity is 0. In the denominator, you just have a positive, plus 1 over 0, 1 over infinity is 0, minus a constant over 0 is 0. So you end up with a positive in the denominator. Negative infinity minus infinity, so that's going to be negative infinity. Okay? Now, suppose you get lost in all of that. Then what could you do if you get stuck in all this algebra?
Put in the calculator.
Put in the calculator. Just look at the graph. I actually think once you do a couple of these, this is actually easier to do it by hand. But but you can do it in the calculator too. All right? So go ahead and try practice 13. I've given you a little bit easier one to maybe do by hand. All right, Joran, when you've got it.
Positive infinity.
Positive infinity is incorrect. All right, let's see what's going on here. Okay, oh, did your graph look something like this? Because I saw you hitting the calculator. Did you put it in? Okay, so let's talk about interpreting the graph before we actually look at the algebra. See, the graph does go to positive infinity as x approaches infinity. But see, the question is, as x approaches negative infinity, do you see, Jordan, the graph is going down to the left? Okay, so if this were x approaching positive infinity, your answer would be infinity because it's going up. But when the x's are going negative, the graph is going down. So it would be negative infinity at that point. Does that make sense? Okay.
Yes.
Okay, so now let's look at the let's look at the algebra here. So, you know, with the power bigger in the numerator, then your answer is either infinity or negative infinity. Okay? So, so now you divide by the highest power of x in the denominator, which is just x. So x squared over x is just x minus, okay, so let's see. Okay, when we're actually plugging in infinity or negative infinity, you don't really draw the limit anymore. So this would be, so negative infinity minus a constant over a constant over infinity is 0. X over x is going to be 1. And then minus 2 over infinity would go to 0. So then that gives you negative infinity over 1, which is negative infinity. Okay? Okay, any questions on the algebra or the graph on that one? Okay. Okay, so now this is just the delta epsilon with the limits at infinity. And basically what I'm going to just focus on is instead of requiring f of x to lie arbitrarily close to the limit, we require f of x to lie arbitrarily far from 0. Now, I'm just going to tell you right now on the chapter 2 test, I'm not going to do delta epsilon questions with infinite limits. Okay? So this part right here is not going to be on the test. It could be on the quiz, but it's not going to be on the test. So we're trying to, so let's go back to the delta epsilon idea. So you remember we pick a delta. That's the how far off we can be off from our target. But since the y value goes up to infinity, we just say that it's going to reach a y that's an arbitrarily distant from the x-axis, from 0. So how far do you want it to be from 0? As far as you want. So you can pick your point as far from the x-axis as you want, and we can get there. That's the idea of that. So here, okay. So this says to prove that as x approaches 0, the limit of -1 over x squared is negative infinity. Okay. So let's just kind of do this together. So we're going to choose epsilon to be some negative value. Okay. You can arbitrarily far from 0. That means you can pick anything you want. Okay. Now I happen to pick -12. So we're picking our epsilon to be arbitrarily close to negative infinity. And then we're going to find a delta that works for that. Okay. So the delta epsilon says, so let's try a delta. So of 2. So if I pick 2, then I would have -1 over 2 squared. That's -1/4. So -1/4 is just barely below the x-axis. That's not farther than -12. So that one didn't work. So what would be another delta that I could pick? What would be a value for x that I could pick that would work in this, where -1 over x squared would be more negative than -12?
It would have to be a fraction, right?
Okay.
Or a decimal.
Keep talking. Well, -12 could be a fraction or a decimal.
Yes, it would have to be closer to 0, right?
Yes, you want to pick one closer to 0. Very good. I think both of you were thinking along the same line. So what would be one to pick? So pick something closer to 0.
If you're trying to get -12 exactly, you could do 1/12.
Okay. Well, so for x, pick 1/12. Let's see. 1/12 squared would be 1/44. So that would give me -144. So, but that would work. That would work because that's greater or less than -12. Okay. So that actually would be a correct answer. So let's say if I choose choose 0.001. Well, -1 over 0.001 squared would be -1 million. So that one works. But what did you say? -112 or +112, -112. All of those would work because it's actually going to approach on both sides. It's going to approach on both sides of 0. It's going to go down. So any value on either side as we get closer to 0 is going to work. So using the delta epsilon, the idea is whatever epsilon you choose, we can find a delta that works. Okay? So that's all we're going to do with that. And again, that's not going to be on the chapter 2 test. All right? Any questions on that? All right. Okay, so with the vertical asymptotes, there we go. We lost Mogyan for a minute. At vertical asymptotes, that's where I'm interested in what happens on either side. So if one side of the vertical asymptote, say goes to infinity, and the other side, the limit goes to -infinity, then the limit in general does not exist. Now with horizontal asymptotes, you're interested in what happens as x approaches infinity. So here's x is approaching infinity and the limit approaches 0. Here, as x approaches negative infinity, the function approaches 0. So really, you'll often have questions at the asymptotes, horizontal or vertical. Okay? Okay, so let's see. To find the vertical asymptote. Oh, wait, let's go back. The line x equals a. I don't think I did that. Okay, the line x equals a is a vertical asymptote of the graph of the function y equals f of x if either the right-hand limit goes to positive or negative infinity or the left-hand limit goes to positive or negative infinity. If either of those happen, then it's a vertical asymptote. Now, I realize we're doing a certain amount of repeating ourselves here, but I'm just trying to focus on different ways that the questions are asked. Okay? So to find the vertical asymptote, that's where you set the denominator equal to 0 and solve. Now, if you have a factor that cancels, it doesn't create a vertical asymptote, but a hole. To find the horizontal asymptote, that's where you take the limit as x approaches infinity. That's what we do in calculus. Or compare the powers in pre-calculus. And then to find the oblique asymptote, is that on there? No.
No.
But you can put that in. That's where we already talked about it. To find the oblique asymptote, do the polynomial division. Okay, so go ahead and do practice 15. All right, so Rhett, what are the vertical asymptotes of number 15, practice 15?
Is the vertical 2 and then the horizontal 0?
Okay, so the vertical asymptote. Okay, now you need to make sure you put x equals for your vertical asymptote because those are vertical lines, and put y equals for your horizontal asymptotes. But I think you got them both right. Okay, so y equals 0 is your horizontal asymptote, x equals 2 is the vertical asymptote. And it didn't ask for the hole, but there's also a hole at x equals -2. Okay. So, great job, Rhett. Any questions on either of those? Any of that? Okay, so it says the next line, the blank, it says horizontal asymptotes, or graphs may approach a horizontal asymptote from, and the answer is above or below. So see how this side of the graph approaches the horizontal asymptote from above, this side of the graph approaches it from below. So it can approach a horizontal asymptote from either side. All right, an even function is symmetrical to the y-axis, and so are its vertical asymptotes. So if you have an even function, it means it's symmetrical to the y-axis. So you imagine if you could fold your paper, one side is the mirror image of the other. Okay, so the asymptotes are as well. All right, so go ahead and do practice 16. All right, so Hannah Z, when you've got it.
X equals plus or minus 3 and y equals 0.
Okay, x equals plus or minus 3 and y equals 0. Oops. Oh, I guess I don't have them written down. So you're absolutely right. So x equals plus or minus 3, y equals 0. Okay, any questions on that?
Can you go over just the horizontal asymptote, please?
Sure. So for the horizontal asymptote, you find the limit as x approaches infinity. So the way we do that is we compare the powers. So since the power in the denominator wins, it's y equals 0. That's it. If the denominator wins, it's y equals 0.
Mr. Strong.
Yes.
So for the horizontal asymptote, what if your numerator has the bigger power?
Then it won't have a horizontal asymptote. Instead, you have a slant asymptote.
Okay.
Okay? And that's where, to find that, that's where you do the polynomial division. So if the denominator wins, it's y equals 0. If they tie, it's y equals a over b, the leading coefficients. And then if the numerator wins, then there is no horizontal asymptote. Okay? All right, so which of the 6 basic trig functions have infinitely many asymptotes? All right, so I wish I could have you come to the board, but we'll just have Nathan. All right, so let's start with this sign. No vertical asymptote or infinite number of vertical asymptotes?
No vertical asymptote.
Whoops.
Yeah, that one. Oh, okay.
All right, how about tangent?
Infinite.
Infinite. And cosine?
No vertical asymptote.
Cosecant?
Infinite.
Cotangent?
Infinite.
Secant?
Infinite.
All right, it's infinite. Let's see what happens if we try to get in the wrong ship. Oh, we're kicked out. Okay. All right. All right. Any questions on that? Okay. So it just says for 17, graph cosecant and cotangent. I'll just let you do this from your calculator or whatever. But remember with these, they do have the red lines are the vertical asymptotes. So they don't show up on your calculator. So make sure when you're graphing these that, like for cosecant, the vertical asymptote is the y-axis and then every pi. So a lot of times what I'll do, even in the calculator, is I will graph sine first and then cosecant. Okay? And then cotangent also, it has everywhere that the sine is 0, that's where you're going to have a vertical asymptote because you get a 0 in the denominator. So that can kind of help you keep it straight as far as where those vertical asymptotes occur. All right? So I'm going to just let you, because I want to finish this up. Okay, so if graphs appear identical on a large scale, the limit of the ratio of the functions as x approaches infinity, that limit will be 1. So when you do a limit as x approaches infinity and you get 1 as you compare two graphs, then it will look the same. See how, like, what we mean by on a large scale is, see these two graphs. Okay, this blue one is 3x to the 4th plus 2x cubed, blah, blah, blah. The red one is just y equals 3x to the 4th. Okay, so when you zoom in, you can tell that they're different. But as you zoom out, because they both have 3x to the 4th, where the powers are the same and the leading coefficients are the same, when you compare the powers and they tie, 3 over 3 is 1. So if that limit is 1, then that means on a large scale, they will look exactly the same. Okay? All right, so then the last question is, wait, what did I skip that one? Okay, so will those graphs appear identical on a large scale? So, what do you think? Yes? Thumbs up
Yeah.
or no?
Yeah, they're the same power.
They're the same power. So if they're the same power, now they have to have the same numerical coefficient as well. So if they were both x to the 3rd and this one was 4 x to the 3rd, then it wouldn't be. They wouldn't be the same. But when they have the same power and the same coefficient, in other words, their limit, as you put one over the other as x approaches infinity, is 1, then they will be the same. So, yes. All right. Okay, so that's it for 2.6, and that's also it for chapter 2. So, but it's going to take us a while, 2 weeks before we take the test. So, anyway, so just be working on that, be practicing those problems, and then tomorrow we'll start in on chapter 3. All right, any questions, concerns before we call it? All right, thanks you guys. We'll see you.